Let's continue with our example of Jake producing pizza. Recall that in the short run, at least one input is fixed. For Jake, the input that is hardest to vary is his pizza oven. So we will continue to assume that his capital is fixed in the short run and that to produce more or less in the short run, he can only vary the amount of labor he hires. Since capital is fixed, the cost of his capital is a fixed cost. A fixed cost is a cost that does not vary with output. His labor is a variable cost. A variable cost is a cost that does vary with output. Total cost is the sum of fixed cost and variable cost. Let's assume that the hourly fixed cost is $100. Let's also assume that the cost of each unit of labor is $20 an hour. In the table, we have entered $100 for the fixed cost. You can see here that fixed cost does not vary with output. Whether Jake produces 0 pizzas or 25 pizzas, his cost in the short run is $100. Given that the hourly wage rate is $20, what is the variable cost for each level of output? What is total cost? Please fill out the table and then answer the question, what is total cost when 20 pizzas are produced? To calculate the variable cost, we simply multiply the units of labor times the wage rate for each unit of labor. To produce 20 pizzas, Jake must hire 4 workers, and each of these workers will cost $20 an hour, so the variable cost will be $80. Adding up fixed cost and variable cost, we get a total cost of $180 when 20 pizzas are produced. Here is what the typical graph of total cost and variable cost looks like. The vertical distance between the two curves is fixed cost. This is the same at any quantity because fixed cost is fixed. That is, it does not vary with output. When making business decisions, it is often helpful to calculate the average of fixed, variable, and total cost. Average fixed cost is the fixed cost per unit of output. The average variable cost is the variable cost per unit of output. The average total cost is the total cost per unit of output. You can also calculate the average total cost as the sum of average fixed cost and average variable cost. Marginal cost is the additional cost from one additional unit of output. You can find it using total cost or variable cost because the change in total cost is the same as the change in variable cost. This is because there is no change in fixed cost from a change in quantity. Please take a minute and calculate the values for the last 4 columns in the table. What is the marginal cost of the 4th worker? Here I use the change in total cost to calculate the marginal cost. As Jake hires the 4th worker, output increases from 16 to 20, and total cost increases from 160 to 180. Thus, the marginal cost of the 20th pizza was $5. This is the additional cost of one additional pizza between 16 and 20 pizzas. Here is what the typical average and marginal cost curves look like. Average fixed cost is the vertical distance between average total cost and average variable cost. This is because average fixed cost is equal to the difference between average total cost and average variable cost. As quantity increases, average fixed cost decreases. This is because fixed cost does not change. As Q increases, you're dividing by more and more in the average fixed cost equation. So the vertical distance between the average total cost curve and the average variable cost curve becomes less as Q increases. The slope of the total cost curve is marginal cost. To see why, note that the slope of the total cost curve is the change in total cost over the change in quantity. This is the rise over the run. Also, the slope of the variable cost curve is marginal cost. That is, the slope of the variable cost curve is the change in variable cost over the change in Q, which is also marginal cost. So for any given quantity, the slope of total cost and the slope of variable cost are the same. The white dashed line is where the slopes of both total cost and variable cost hit their minimum. Since the slope of both of these curves is marginal cost, this is also where marginal cost hits its minimum. The relationship between marginal cost and average total cost is similar to the relationship between marginal product and average product. When marginal cost is less than average total cost is decreasing. When marginal cost equals average total cost is at its minimum. And when marginal cost is greater than average total cost average total cost is increasing. These relationships are also true for marginal cost and average variable cost. Why is it that marginal cost initially declines and then increases? Turns out the shape of the marginal cost curve is driven by the shape of the marginal product curve. Each worker costs $20. The marginal product of the first worker is 5. This means that when the first worker is hired, 5 additional pizzas are produced. Since this worker costs $20, it costs $20 additional to produce 5 additional pizzas. This implies that the marginal cost or additional cost of one additional pizza is $4. This equation summarizes the logic. To get 5 additional pizzas required a wage of $20 to be paid. Thus, the marginal cost of the 5th pizza is $4. How about for the 11th pizza? To get the 11th pizza, a second worker must be hired. The marginal product of this worker was 6. So when you pay $20 for a second worker, you get 6 additional pizzas. Since the marginal product has increased, the marginal cost has decreased to $3.33. Intuitively, this makes sense. The higher the marginal productivity, the lower the marginal cost. Each additional worker is going to cost an additional $20. The more productive this worker, the lower the marginal cost of an additional pizza. Finally, consider the marginal cost of the 25th pizza. To get the 25th pizza requires hiring a 6th worker. Diminishing returns has long since set in, so the marginal product of the 6th worker is relatively low. The 6th worker only contributes 2 additional pizzas, but still must be paid a wage of $20. So the marginal cost of the 25th pizza is $10. This graph captures the relationship between marginal product and marginal cost. When marginal product increases, marginal cost decreases. When marginal product hits its max, marginal cost hits its minimum. Then, as marginal product begins diminishing, marginal cost begins increasing. Marginal cost is the mirror image of marginal product. Also for the same reasons, average variable cost is the mirror image of average product. Let's work some problems. Suppose when 60 units are produced, the average variable cost is $4 and the average total cost is $6. What is average fixed cost? Average fixed cost is equal to the difference between average total cost and average variable cost. When output is 60, average fixed cost is 2. Graphically is the vertical distance between the average total cost curve and the average variable cost curve when quantity is 60. When quantity is 60, what is total cost? To solve this problem, we will rearrange the average total cost equation. The fact that average total cost equals total cost divided by quantity implies that total cost is equal to average total cost times quantity, which is 360. Graphically, this is equal to the area of the blue rectangle. When you multiply height times base, you get the area of the rectangle. Here, the height of the rectangle is equal to average total cost, or 6, and the base is equal to Q, or 60. So when you multiply the height times the base, you're actually multiplying average total cost times Q, which is total cost. We can plot this value of 360 for total cost on the top graph. When quantity is 60, what is variable cost? The approach here is very similar to the approach in the last problem. First, we will rearrange the average variable cost equation. The fact that average variable cost equals variable cost divided by quantity implies that variable cost is equal to average variable cost times quantity, which is 240. Graphically, this is equal to the area of the gray rectangle. Again, when you multiply height times base, you get the area of the rectangle. Here, the height of the rectangle is equal to average variable cost, or 4, and the base is equal to Q, or 60. So when you multiply the height times the base, you're actually multiplying average variable cost times Q, which is variable cost. We can plot this value of 240 for variable cost on the top graph. We can add fixed cost to this graph too. This is the area of the orange rectangle. Once again, the equation for average fixed cost can be rearranged to get fixed cost. If we add up these areas of the fixed cost rectangle and the variable cost rectangle, we get the area of the blue total cost rectangle that we solved for earlier. The understanding we have gained here will help us to make short-run business decisions for firms in perfect competition and other market structures. Betty's Burgers is considering hiring a 10th worker. The worker would add 5 additional burgers to the production process each hour. The hourly wage is $10. What is the marginal cost of 1 additional burger produced by this 10th worker? Recall that this equation shows the relationship between marginal product of labor and marginal cost. Here the employer will pay a wage of $10 to get 5 additional burgers. So the marginal cost of 1 additional burger is $2.50. When the 100th bicycle was produced, the total cost of production was $10,000 and fixed cost was $4,000. The marginal cost of the 100th bicycle was $80. Which of the following is true? Here, average total cost is $100 and average variable cost is $60. Since marginal cost is less than average total cost is decreasing. And since marginal cost is greater than average variable cost is increasing. Let's work another problem. Suppose that the following diagram represents the cost curves for Betty's Burgers. Which of the following will shift the average total cost curve and not the marginal cost curve, or average variable cost curves? The key to this problem is understanding that what will change average total cost curve while leaving average variable cost and marginal cost unchanged is a change in fixed cost. Recall that in this graph, the vertical distance between average total cost and average variable cost is average fixed cost. When this vertical distance increases from an increase in fixed cost, average total cost shifts up, but average variable cost and marginal cost remain the same. The only example of fixed cost in this list of options is the increase in the rental rate for the restaurant building that Betty owns. The cost of the restaurant is fixed in the short run because it does not vary with output. It may change over time, but it does not vary as Betty changes the number of burgers she produces in a given month. All the other costs are variable costs. They vary with output. When a variable cost increases, all of the cost curves shift up, but average fixed cost does not change. This implies that the vertical distance between average total cost and average variable cost does not change. Here we have drawn all of the original cost curves in pink and all of the new cost curves in yellow so that they are easier to see. The vertical distance between average variable cost and average total cost remains unchanged because average fixed cost does not change when there's a change in variable costs. An increase in the market wage, the price of electricity, or the price of beef are all examples of changes in variable cost.